This video is over properties of equality and operations. That is our title for today. So we have properties of equality and operations. And you have used these a lot, but you just haven't formalized the names for them. My title isn't fitting. There we go. All right. So in order to solve, we're on our mini lesson part, in order to solve equations in algebra, you must perform operations that maintain equality on both sides of an equation. And the way we do that is we use the properties of equality. Of equality. I'm going to put EQ for equality. These properties are rules that allow you to balance, manipulate, and solve equations. And we're familiar with balancing equations. We did that yesterday in our work session practice. And then we've also manipulated equations to help us solve them. So we're going to talk about the properties of equality, and it looks like a bunch of them, but honestly, they're things that seem intuitive, and what that means is they're things that seem like common sense. And again, you've used these in the past. We're just kind of formalizing them with the name. So our first property is called the reflexive property of equality, and it basically means that a number is equal to itself. So our example would be x is equal to x, or 3 is equal to 3. Our next one is called the symmetric property of equality. So we kind of have an idea of what symmetry is, but in words, it says if the numbers are equal, then they will still be equal if the order is changed. So that would be something like x plus 2 is equal to 2 plus x. Those are exactly the same thing. The transitive property of equality, that's our third one. If the numbers are equal to the same number, they will also equal to each other. So that's like saying if x equals 3 and 3 equals y, then x must be equal y in that case. If x equals 3 and 3 is also equal to y, then x and y must also be equal. Now, the ones that you're really familiar with are the next 5. The first one here is addition property of equality, and it basically says if you add the same number to both sides of the equation, it doesn't change the equality of the equation. So if we had something like x minus 3 equals 7, and you added 3 to both sides, we would get x equals 10. Adding the same thing to both sides of the equation, the reason why we're able to do that is the addition property of equality. Subtraction property of equality, very similar. So here, if we had x plus 2 equals 6, if we subtract the same amount on both sides, we would get x equals 4. The equation x equals 4 and x plus 2 equals 6 are the same. They're equivalent to one another. All we did was subtract the property, we subtracted the 2 from both sides, and the reason why we're able to do that is the subtraction property of equality. The multiplication property of equality, what that is if we have a number divided by 2, we'll say equals 5, for instance. If we multiply each side of the equation by the same number, that is allowed. We are allowed to do that because of the multiplication property of equality. If we multiply both sides of an equation by the same number, it doesn't change the equality of the equation. The division property of equality. Let's say we had 3x equals 6. If we divide both sides of the equation by a number, in this case 3, it does not change the equality of equation. 6 divided by 3 would give us 2. So it's kind of self-explanatory, the addition, subtraction, multiplication, and division properties of equality. It's basically why we're allowed to use inverse operations when we solve an equation. Like, again, on the subtraction one, when we look at that, the reason why we were even allowed to say subtracting 2 on both sides is because of this property. Our last one is the substitution property of equality, and that's basically saying that if we know what x is equal to, let's say x equals 6, then we can substitute that into an equation to figure out another variable. So let's say we had y equals 4 plus x. Since we know what x is, we know x is 6, we could substitute a 6 in for x. So we would have y equals 4 plus 6, and y would be equal to 10. Those are our properties of equality. We also have a few properties of operations. And these ones you've actually been learning about for a really, really long time. Let's look at those three. Properties of operations. We've got the commutative property of addition and multiplication. So that addition commutative property basically says that if we switch the order of the add-ins or the things that we're adding, it'll still be the same equation. So for instance, 8 plus 3, or 3 plus 8 is equal to 8 plus 3. As far as the multiplication commutative property goes, we could say that 3 times 8 is equal to 8 times 3. They're both the same thing. The associative property says that we can move around the grouping symbols or the parentheses of an addition or a multiplication problem, and it would still give us the same answer. So an example for adding, oh, that went lower than I wanted it to. An example for adding, what we could say is that 3 plus 8 plus 2 is also equal to 3 plus 8 plus 2. And notice how the only thing that changed was the grouping symbols. And then for multiplication, I'll do that one in a different color. I'll pick pink for this one. For the multiplication ones, the same concept applies. 3 times 2 times 3 is also equal to 3 times 2 times this 3, like that. Again, notice that the parentheses just moved over. It's basically saying that we can associate different numbers with each other without changing the balance of the equation. And then the distributive property of multiplication, we know this. We've studied this for a while now in Unit 1 and this unit. For the distributive property of multiplication, it basically says a number on the outside distributed to a quantity on the inside, like x plus 2, should come into play. I don't know why it's like sideways like that. Sorry, that should be one big parenthesis. That is equal to 3x plus 6. And the reason why is because we distribute the number on the outside to the quantity on the inside. Now, how we actually use these properties is on the back. Here, what you're looking at is an equation, and it's already solved for you, and you just have to pick out which property of equality is missing in the steps to solve the equation. So if you notice, our first step is always the original equation. That's what we're given. That's always going to be given to you. This is the original equation. Now, if we look from step 1 to step 2, what it looks like happened is we lost this 22, and the 50 became a 28. I know by using inverse operations that we must have subtracted 22 on both sides. And that's right, 22 minus 22 cancels, and 50 minus 22 is 28. Knowing this, the operation that I did was subtraction, and I was allowed to do the subtraction because of the subtraction property of equality. If we were to follow through, when I divide both sides by -7, I'm allowed to do division because of the division property of equality. Let's look at our next one. For this one here, it looks like our original equation was given. It was -3 minus x divided by 6 equals 4. Here, by the addition property of equality, I added 3 to both sides. So that step told me addition property of equality. From this step to this step, from step 2 to 3, it looks like that 6 went away. I was dividing by 6, so the inverse of dividing is multiplying. So I must have multiplied both sides by 6 to get here. And I know I'm right because 7 times 6 is 42. So the reason why I was able to go from step 2 to step 3 is the multiplication property of equality. Property of equality. And again, I'm just going to abbreviate equality. Here's our last one, and then you'll try the work session in a minute on your own. The original equation that we were given is right here. This is kind of a more complicated one. We had to use the distributive property, and y'all knew that because, hey, look, I see that parentheses and a number on the outside. After we do the distributive property, we would have gotten 3x plus 12. That 5x stays, so does the 28. The next step is we combined like terms. So notice how that 5x and 3x became 8x. So we combine like terms. Now, it says that we're from go to this step, we use the subtraction property of equality. So let's think about that. If we use the subtraction property of equality to go from step 3 to step 4,